Lesson. Read a graph. Mankind invented a system to cope with the fact that we are so intrinsically lousy at manipulating numbers. It's called the graph. Charlie Munger. The domain of a function refers to a set of possible input values. The domain of a graph consists of all the input values shown on the x-axis. This graph continues beyond the portion of the graph we can see. We can observe that the graph extends horizontally from -5 towards right with no bound. Thus, the domain is closed interval -5 infinity. The range is the set of possible output values which are shown on the y-axis. The vertical extent of the graph is all values 5 and below. So the range is -infinity closed interval 5. The function graph is continuous. We can observe that the graph extends horizontally from -3 to 1. There is a hole at x equals -3, so -3 is excluded from the domain. Consequently, the domain is open interval -3, 1 closed interval. The graph extends vertically from -4 to 0. There is a hole at point -3, 0. However, the point 0, 0 belongs to the graph. Thus, y equals 0 belongs to the range. Consequently, the range is closed interval -4, 0. Question 1. The graph of function f is given below. Find the A domain. The domain is equal to the set of x's such as point of coordinates xy belongs to the graph of function f. To find the domain, we are going to project the points of the graph on the x-axis. And as we project all these points, we run into the point of coordinates -10, 10. And since we have a hole there, we project the hole onto the graph. Continuing on, we project the rest of the points of the graph till we get to the point 10, 5 right here, where there is yet another hole, and we project that onto our x-axis. And that occurs one more time at the point of coordinates 20, 10. The domain is thus equal to the set closed interval -15, -10 open interval, united with open interval -10, 10, united with open interval 10, 20. The graph extends horizontally from -15 to 20 with interruptions at -10, 10, and 20. B. The range. The range is equal to the set made of y's such as the point of coordinates xy belongs to the graph of function f. To find the range, we are going to project the graph of the function on the y-axis, similar to what we did when we found the domain. So we begin projecting until we encounter our first hole. The point of coordinates 10, 5 is missing from the graph of f. However, there is a point P on the graph of f with the y-coordinate equal to 5. Thus, 5 belongs to the range of the function. We continue projecting. There are 2 points with y-coordinate equals 10 missing, A and B. However, the point R is on the graph and has the y-coordinate 10. Thus, 10 belongs to the range of the function. The range is equal to closed interval -5, 15. The graph extends vertically from -5 to 15 inclusive. C. X-intercepts. All the points where the graph of the function crosses the x-axis. The graph intersects the x-axis at A, point of coordinates -14.8, 0. Y-intercept. The point where the graph of the function crosses the y-axis. The graph intersects the y-axis at point B of coordinates 0, 15. E. Intervals on which f is increasing. A function is increasing if we move continuously to the right along the x-axis and the graph is going up. The graph rises from point C to B and from point E to F. However, the point D doesn't belong to the graph, thus it is going to be excluded. In conclusion, f is increasing on open interval -15, -10, united with open interval -10, 0, united with open interval 10, 20. Important note, intervals for increasing and decreasing are always open intervals. This is the reason we took open interval at -15, even though the function is defined at x equals -15. The graph of function f is shown below. Solve a f of x is greater or equal to 5. That is equivalent to x belongs to the domain of f, such as the points on the graph of f are above the line y equals 5 or on the line y equals 5. As we move to the right on the x-axis, the points on the graph must have y coordinates bigger or equal to 5. This shaded section is entirely above y equals 5. The following section is under. This point right here, 15.5, is exactly on the line, and then the remaining part of the graph is under the line. Thus, f of x greater or equal to 5 is equivalent to x belongs to open interval -15, -5, united with the set made of 15. We took an open interval at -15 and -5 because both values are not in the domain of f. Remember, they are wholes. We united the open interval with the set made of 15 because the point 15.5 belongs to the graph of the function. Thus, it satisfies the inequality of the problem f of x greater or equal to 5. Set of solutions of the inequality was, as we said, open interval -15.5 united with the set made of 15. Part B, f of x is greater or equal to 0. X belongs to the domain of f, such as the points on the graph of f are above the x-axis or on the x-axis. This section above, on the line y equals 0, then under, then yet again 3 points are actually on the line y equals 0, 0, 0, and 2 mystery points that we'll find out exactly. This little section's above, and then finally under. As we move to the right on the x-axis, the points on the graph must have the y-coordinates bigger or equal to 0. To solve the inequality, we must find the coordinates of the x-intercepts O, D, and E. To find the coordinates of D and E, we must write the equations of the segments AB and BC. Slope of AB is equal to YB minus YA over XB minus XA, which is equal to 5 plus 5 over 15 minus 10, which equals 10 over 5, which then equals 2. Slope of AB is 2. The equation of line AB, we use what we know the equation of a line to be, which is y minus yb equals slope times the quantity x minus xb, equivalent to y minus 5 equals 2 times the quantity x minus 15. To find the coordinates of point D, we must solve the system of equations y minus 5 equals 2 times the quantity x minus 15 and y equals 0. Plug in y equals 0 from the second equation into our first equation to obtain negative 5 equals 2x minus 30. Add 30 to both sides of the equation, which is equivalent to 2x equals 25. Divide both sides of the equation by 2, equivalent to x equals 12.5. D is thus point of coordinates 12.50. Now let's solve for e. Slope of BC is equal to YB minus YC over XB minus XC, which is 5 plus 20 over 15 minus 20, which equals 25 over negative 5. Simplified, slope of BC is equal to negative 5. The equation of line BC is y minus YB equals slope times the quantity x minus xb. Y minus 5 equals negative 5 times the quantity x minus 5. To find the coordinates of point E, similarly, we must solve the set of equations like we did for D. Y minus 5 equals negative 5 times the quantity x minus 15, and y equals 0. Thus, negative 5 equals negative 5x plus 75. Let's add 5 to both sides of the equation along with positive 10x to obtain 5x equals 80. Divide both sides of the equation by 5, equivalent to x equals 16. Thus, the set of solutions of the inequality is open interval negative 15, negative 5, united with open interval 5, 0, closed interval, united with closed interval 12.5, 16. Part C, f of x equals negative 10. The solution of the equation is the x-coordinate of the point of intersection between the graph of the function and the line y equals negative 10. To find the coordinates of point P, we must solve the system of equations made by the equation of line BC and its intersection with the horizontal line y equals negative 10. The set of equations is as follows. Y minus 5 equals negative 5 times the quantity of x minus 15, and y equals negative 10. Substitute negative 10 in the first equation. Thus, negative 15 equals negative 5 times the quantity x minus 15. Divide both sides of the equation by negative 5, equivalent to 3 equals x minus 15. Add 15 to both sides of the equation, equivalent to x equals 18. And the point of intersection is point of coordinates 18, negative 10. The set of solutions of the equation f of x equals negative 10 is the set made of 18. Question 3. The graphs of two functions f and g are shown below. Solve. A, f of x equals g of x. The solutions of the equation above are the x-coordinates of the points of intersection P, Q, and R, which is equivalent to x equals negative 15, x equals 5, and x equals 20. Thus, the set of solutions of the equation is of f of x equals g of x is negative 15, 5, and 20. Part B, f of x is greater or equal to g of x. The solutions of the inequality above are the x-coordinates of all points on the graph of both f and g, such as the graph of f is above the graph of g, or the graph of f is the same as the graph of g. F is above, then f is under for this section, f is above again, and then under g. Thus, f of x is greater or equal to g of x is equivalent to x belongs to closed interval negative 15, negative 8. See, we have a hole at negative 8, so open interval there, united with closed interval 5, open interval 10 due to another hole. Negative 15 and 5 are included in the set of solutions because f of negative 15 equals g of negative 15, and f of 5 equals g of 5. Thus, solutions to the inequality f of x is greater or equal to g of x. Negative 8 and 10 are excluded from the set of solutions, as we said before, because they don't belong to the domains of f and g. The set of solutions of the inequality f of x greater or equal to g of x is closed interval negative 15, negative 8 open interval, united with closed interval 5, 10 open interval. C. F of x is less than g of x. The solutions of the inequality above are the x-coordinates of all points on the graph of both f and g, such as the graph of f is under the graph of g. We can draw it out. F is above, then under, then above yet again, and finally under. So f of x is less than g of x is equivalent to x belongs to open interval -8, 0, united with open interval 0, 5, united with open interval 10, 20. The values -8, 0, and 10 are excluded from the set of solutions because they don't belong to the domains of f and g. The values 5 and 20 are excluded because f of 5 equals g of 5 and f of 20 equals g of 20. Thus, they are not solutions of the equation f of x equals g of x. The set of solutions of the inequality f of x less than g of x is open interval -8, 0, united with open interval 0, 5, united with open interval 10, 20. Question 4. The graph of the function f is shown below. Which of the following is true? Testing 1. Domain equal to -infinity, infinity. The graph extends horizontally from -infinity to infinity. 1 belongs to the domain because the point A of coordinates 1, 1 belongs to the graph. 2 belongs to the domain because the point B of coordinates 2, 3 belongs to the graph. So the domain is -infinity, infinity. Statement 1 is true. Statement 2. Range is equal to closed interval 0, 5. The graph extends vertically from 0 to infinity. 0 belongs to the range because the origin O, point of coordinates 0, 0, belongs to the graph. Therefore, the range is equal to 0, closed interval 0, infinity. So statement 2 is false. Statement 3. The inequality f of x less or equal to 0 has no solutions. The solutions of the inequality f of x less or equal to 0 are the x-coordinates of all the points on the graph of f below the x-axis or on the x-axis. The graph intersects the x-axis at the origin, thus 0 is a solution of the inequality. In conclusion, statement 3 is false, and the correct answer is A, 1 only. Question 5. The graph of the function f is shown below. Which of the following is true? 1. F is an even function. F of -2 is equal to -2. F of 2 is equal to 5. Thus, f of -2 does not equal f of 2. Therefore, f is not an even function. Also, the graph lacks symmetry with respect to the y-axis, which proves that the function f is not even. Statement 1 is thus a false statement. Statement 2, f of -1 equals -1. There is a hole at point of coordinates -1, -1. Thus, f of -1 does not equal -1. There's a point -1, 2 on the graph. As a result, f of -1 equals 2. Thus, statement 2 is false. Statement 3. Range is equal to -infinity, 5 closed interval. The graph extends vertically from -infinity to -1 inclusive and from 1 to 5. The range is open interval -infinity, -1 closed interval united with closed interval 1, 5. Thus, statement 3 is false. In conclusion, the correct answer is E. Question 6. The graphs of functions f and g are shown below. Which of the following is true? A. F of -4 is equal to 2. There is a hole at the point A, -4, 2, and the point B, -4, 3, is on the graph of the function. Thus, f of -4 does not equal 2, f of -4 equals 3. Statement A is false. Statement B. The equation f of x equals 1 has two solutions. The solutions of the equation f of x equals 1 are x-coordinates of the points of intersection on the graph of f and the line y equals 1. This blue line right here. There's only one point that belongs to both. The point 7, 1 doesn't belong to the graph of f, as we have a hole. Thus, statement B is false. Statement C. The equation f of x equals g of x has two solutions. The solutions of the equation f of x equals g of x are the coordinates of the points of intersection of the graph of functions f and g. The two graphs intersect at one point only, p of coordinates 5, 0. 5 is the only solution of the equation f of x equals g of x. Thus, statement C is false. Statement D. Both functions f and g are decreasing on the open interval 0, 4. The function f is not defined on the open interval 0, 1. Thus, f is not decreasing on open interval 0, 4 because f is not defined over the entire interval 0, 4. Statement D is thus false. There is only one choice left. Unless we made a mistake, this must be the correct answer. But let's check it. Statement E. The set of solutions of the inequality f of x greater or equal to g of x is closed interval -2, -1 open interval, united with open interval -1, 0, united with closed interval 1, 4 open interval. The solutions of the inequality f of x is greater or equal to g of x are the x-coordinates of all the points such as the graph of f is above the graph of g or the graphs intersect. Also, the solutions must belong on both domains of f and g. The set of solutions of the inequality f of x greater or equal to g of x is closed interval -2, -1 open interval, united with open interval -1, 0, united with closed interval 1, 4. We included -2 because it belongs to both domains, and f of -2 is greater or equal than g of -2. We excluded -1 because -1 doesn't belong to the domain of g. We included 1 because 1 belongs to both domains, and f of 1 is greater or equal to g of 1. We excluded 4 because 4 doesn't belong on the domain of f. The correct answer is E. Question 7. True or false? The function f is decreasing on the open interval -4, 2. A function is decreasing over an interval I if and only if f of x1 is greater than f of x2, equivalent to x1 less than x2, or f of x1 less than f of x2, equivalent to x1 greater than x2 for all x1, x2 belongs to the interval. -2 is less than 0. We selected our x's. F of -2 is equal to 1.6, and f of 0 is equal to 2. Therefore, f of -2 is less than f of 0. So we found a contradiction. We found two values that contradict the definition of a decreasing function. In conclusion, this statement is false. Question 8. True or false? The graphs of the function f and g are shown below. The sum of the functions f of g is an even function. Both functions have symmetry with respect to the y-axis. Thus, both functions are even functions. The sum of two even functions is an even function. Thus, the statement is true. Question 9. True or false? The graphs of the functions f and g are shown below. The product of the functions f and g is an odd function. The graph of f has symmetry with respect to the y-axis. Therefore, function f is an even function. The graph of g has symmetry with respect to the origin. Thus, g is an odd function. The product of an even and an odd function is an odd function. Thus, the statement is true. Question 10. The graph of the quadratic function f is shown. If the even function g is defined by the equation g of x equals f of x minus h, what is the value of h? Method 1. Use transformations. The function f is not an even function because its graph lacks symmetry with respect to the y-axis. A horizontal shift to the right 1 unit moves the vertex of the parabola to point of coordinates 0, -3. The transformation has the vertex on the y-axis, and its graph has symmetry with respect to the y-axis. G of x equals f of x minus 1. G of x equals f of x minus h. Therefore, h equals 1. Method 2. Use the vertex form of a parabola. V of coordinates -1, -3 is the vertex of the quadratic function f. The vertex form of a quadratic function is f of x equals a times the quantity x minus h, everything squared, plus k, where a, h, and k are constants, and v of hk is the vertex. Thus, f of x equals a times x plus 1, everything squared, minus 3. Therefore, g of x equals f of x minus h equals a times the quantity x minus h plus 1, everything squared, minus 3. An even quadratic function has the equation g of x equals a x squared plus k. Thus, negative h plus 1 equals 0, equivalent to h equals 1. The end.